Okay, welcome back to the second session. Now, here I am going to discuss something. Here I am going to discuss about the signal generation first, then we'll see the analysis. So when you will right click on the block diagram, you will find this signal processing toolkit. Inside the signal processing toolkit, you will get the waveform generation and signal generation. So first come on the waveform generation. In this waveform generation, you will get a basic function generator. You will get here sine waveform, square waveform, triangular waveform, sawtooth waveform. So here I am taking a square waveform. So it's a square waveform. Right click, open the name. Now press Control H. When you will press a Control H, you will it will open a context help. It will open a small window with the name of context help. And after opening this context help, when you will touch your functions, your context help will give you a your small info about your that particular function. Now you can see here in this sine waveform, this one where I am pointing. You can see in the contact help. Okay, that's blinking. So it's my reset signal. It is my offset, it's my frequency, it's my amplitude, and it's my phase. So here I'm going to create same thing for right click, create control, right click, create control, right click, create control, and right click, create control. You can also create okay control functions for all these options. So this one is frequency and amplitude, phase and offset. Right now, here I'm taking the frequency. Right click, replace this frequency with the knob. Now you can see it is frequency. Replace the amplitude with the knob. You can change this one offset. Right click, you can come here and you can take this vertical slider pointer offset. You can change the offset value from -10 to 10. I like this. So how can you change it? Let's see first. Right click, come here, replace its offset. You can change the label from -10 to +10. Its range. You can change the phase. Okay, so you if you want to, you can change the phase and you can create the phase change like this or phase. No need to come with this. Phase is quite enough. Now, right click, come here and take a waveform graph and place here. It's clear for all of you. I have taken one sine waveform and create it a frequency, amplitude, frequency, amplitude, phase, and offset. Now here I am going to take a while loop. Take a while loop and create constant. Means you can take a stop button here. I think it is visible to all of you. Let's run the program. Now you can see my system is generating. Now you can see our system is generating a proper sine waveform. Here I am going to de- reduce the frequency. Now you can see the frequency is near about 1. You can see the speed is very high. So I we can reduce the speed over this algorithm, and the algorithm name is wait function. Now you can increase the frequency like this. Waveform chart is my display unit, and this waveform chart is right now auto scale. So I am going to remove this auto scale functions. When you will right click, when you will right click here, and you will come when you will right click, you will get a shortcut window. On the shortcut window, you will get this X scale. Then uncheck this one. Now you can see X, okay, Y scale. So now in this Y scale, now this one is Y scale, auto scale Y. Okay, is unchecked now. Now here I am going to set it minus 10, minus 10, and it's plus 10. Let's run the signal. Now you can see it's my sine amplitude. Amplitude is near 1. Increase the amplitude. Increase the amplitude is 3. Let's try to reduce the amplitude near 1. Frequency, right? Using this wave offset, you can change by shifting 90-degree phase shift. You can generate a cos wave, and you can stop. So in this way, you can create. In this way, you can generate a signal. In this way, you can generate a signal, a sine wave signal. So if it is clear, so let's go to the storage. How can we store this generated data? First, how can we store this generated data? Okay. So for that, you have to come into right click. You have to come into the file IO. In this file IO, there is right measurement file. Right measurement file is here. So click here and place inside the while loop. When you will place this right measurement file inside while loop, it will open a configuration window like this. In this configuration window, the first one is file name. The second portion is action. Inside the action, the save, okay, and that rename, use next available frame, file name, okay, append, override other options. So this portion is not important here. The important portion is this one, file format. Our human readable file is binary, Microsoft Excel. So Microsoft Excel, select here, and we need a time also. One column, one column only. Then we need to identify. We need to find a location. We need to create a directory. So my location will be here. This document. Inside the document, if I will create a new folder for triple IT Delhi, and if I will select this triple IT Delhi inside okay, inside sign data. Okay, now you can see here LabVIEW data, triple I Delhi sign data. Press the OK button. Great. Let's come here and let's try to find out. is my document, LabVIEW data, triple IT Delhi, Delhi. Here I am going to run the program. Okay, now increase the amplitude, reduce the frequency, stop the program. Now you can see here the sign data file is available here. Sign data.txt file is generated. So in this way, you can store your data easily on your PC. 17th September 2022, 2:21 PM ये आपका टाइम है और आप ऐसे डेटा को स्टोर कर सकते हैं. ठीक है, लेट्स गो टू द अनदर एग्जांपल. इट्स क्लियर फॉर ऑल ऑफ यू. Now here I am going to remove. Now here I am going to remove the while loop. So how can we remove the while loop? So for that, right click, remove the while loop. It's our okay, right my own file. Remove this one. Stop button also remove. Wait function remove. Now here I am going to set the frequency, offset and others. Constant. Constant frequency will be 10. Constant amplitude will be 1. Con constant phase will be 0. Offset signal will be a 0. As earlier I mentioned, a waveform graph is a collection of three things. A waveform graph is a collection of three things. Del T, T0 and Y array. In the first session, we'll discuss. So let's try to do some operations. Okay. So for that, right click, come here. There is a waveform. In this waveform, it is waveform function palette. Inside the programming, you will get the waveform function palette. Inside the waveform function palette, you will get a get component option. Get waveform component option is this. Make a connection like this and increase it. Now you can see Y array, attributes and attributes. When you will click on the attributes, you will get del T0, del T and Y array. So Y array is also available. So here I am going to select del T0 and del T. What I will get, okay. So what we will get using the Y array? Y array will provide us the all data, all necessary data who are responsible to create this signal. Now, if I will ask you how many samples are available or how many data points are available are present, how many data points are present on this signal, how many data points are present on this signal. So how can we find out how many data points are present on the signal? Using these data points through this, okay, due to these data points, we are able to see the signal. If here I will write 0.01, 0.002. Just a second. Okay. 0.002. 0.002. If I will come here and if I will write 0.002, so now you can see the first data is 0 is there and second data is this one. And the value of this data is 0.6, 0.627. Okay, and this one is 0.1, 0.06, and 0.12. So now tell me how many data are present on this signal. How can we find out? We know very well this sine waveform function is generating a signal, sine signal. We can watch that signal using this waveform generator. Okay, we can watch this. We can see the data using this waveform generator. Clear? Now using this get waveform component, we are able to break down and we can access the value, that particularly value intensity who are responsible to create this signal. Now the question is again, how many points are here? So to now you can see the data are present in array. So we need to count the array. We need to find out the array size. You have to come here and you can take the array size and you can present the array size. You can collect, run. Now you can see the 1000 data are here. The 1000 data are present on this signal. On this signal, there are 1000 data who are creating this sine waveform. Now, what is the time interval? What is del t? Del t is 0.01 second. Del t is 0.01 second. So, if the del t is 0.001 second, 0.001 second. If the delta is 0.001 second, so now how can we find out how much second it will take to display all the 1000 data? If the delta is 0.001 second, so how much time it will take to display 1000? How much second it will take to display 1000 data? So for that, we need to take a multiply functions, multiply the number of element or the number of, okay, uh yes, wire element, multiply with the del t. So you will get that second. It will take nearly 1 second to display all the 1000 elements. Now you can see the x scale is the x scale range is 1 second. X scale range is for 1 second. Is clear?
So using these components, we can again generate a waveform, right?
Yes. We can again generate. Suppose how can we do? Let's see. Suppose I want to count how many elements are, how many data points are greater than, how many data points are greater than 0. How many data points are positive? How many data points are positive? So for that, we need a function, and the function name is comparison. The value should greater than 0. Greater than 0. The value should greater than 0. It is a kind of object count option. It will be give you the true and false condition for all those values who are greater than 0, means who are positive. Okay, and using these functions we can convert all the 0 and all the true and false into the 0 and 1, and using this function we can add all the 1 and 0, all the 1 and 0, and you can, and we can measure, and we can measure and say कि 499 499 data points are positive. 499 data points are greater than 0. Suppose you are receiving a data through over the internet, over your network, okay, from cloud or from your USRP place setup. If you are receiving a data in the form of graph and you want to find out the result, and you are not a big programmer and you don't have any algorithm, so you can design your own algorithm like this. You can write your own code to get the proper informations. Okay. Now, so this portion I am going to delete. I am going to fix the frequency 5. Nice. There is one more sampling info. Create control the sampling info. Here, the sampling rate is 1 kilohertz and the number of sample is 1 kilo. Sampling rate is 1 kilohertz. What will happen if the sampling rate and sample? If the sample is 100, then what will happen? If the sample is 100, then we'll get the signal like this, half signal. Okay, here I'm going to set it 10. If sample is 100, if sample is 100 and the sampling rate is 1000, 1 kilohertz means sampling rate is 1000. Okay, so we will get the signal like this. If the sampling rate is 500, sorry, is the number of sample. So number of sample means number of data points. If the number of data points is 500, means the number of sample is 500. So we will get the signal like this. If the number of sample is 250, means the data points, the Y array data points are 250. So we will get the signal like this. If the number of sample is 200, sorry, 2000, if the number of sample is 2000, means the sample the rate number of sample is 2000, means the data points is 2000 on that array. So how the graph will look like? So graph will look like this. It's taking near about completely 2 seconds. Okay, 2 seconds to display. Suppose in place of 1 kilohertz, my sampling frequency is 2 kilohertz. In place of 1 kilohertz, the sampling frequency, the sampling range, the sampling frequency is 2 kilohertz. So we will get a signal like this. Now you can see here, I'm going to use the same functions again, get waveform component. Now you can see it is 0.0005, 0.0005, 0.0005. Okay, so now you can find out the time difference between 2 point, time difference between 2 point, del t. If it is clear, so we can go to the next step. Sampling rate. Right click, come into the unbundle by name if possible. Here I am taking the unbundle functions. Unbundle functions. This unbundle functions has sampling frequency. So what is the sampling frequency? 2 kilohertz. 2 kilohertz. If I will say 1 by 2 kilohertz, if I will take 1 by 2 kilohertz, then same number I will get. It will based on the sampling frequency, not number of sample. If the number of sample will be 1000, so time will be 0.5 seconds. If you really want to calculate the number of del t, okay, if del t, if you really want to calculate the del t, so you need to understand, you need to clear yourself about the sampling rate. If the sampling rate is clear to you, that means the del t is clear. If del t and sampling rate is clear, that means you can say how much time your system is taking to pick a sample. कितना जल्दी आपका सिस्टम एक सैंपल पिक करता है, इसका अगर आपको पता लगाना है, ओके, सो उसके लिए आपको सैंपलिंग रेट क्लियर रखना पड़ेगा. There is one more function, that is built waveform functions. Built waveform. Build waveform. In this build waveform, I can connect del t like this. Sorry, Y array. I can connect del t like this. Take a waveform graph again. Okay, let's see. I'm trying to. Now you can see here. In this way, you can modify your program and you can set your current time also. Right click here, come into the signal processing, waveform generation. In this waveform generation, there is one basic function generator. In this basic function generator, right click, take a label, open the label, press Ctrl H, it will open a context cell for you. Then press the basic function generator. When you will click it, you will get some info. Offset, where is the offset? This one is offset. This is the reset signal. This is signal type, frequency and amplitude others. I know All of you are very much aware about the frequency, amplitude, phase from the last example. Also, the offset. The new thing is signal type. Here I am going to create a signal type. Now you can see this is my signal type. In this signal type, you will get a sine wave, triangular wave, shortwave wave, square wave. So we call it is a enum data type, enumerated data type. It is a different kind of data types. Okay, we'll see later how can we use this enumerate data type, how can we utilize this enum data type, how can we create this enum data type. Now, so here I am taking one waveform graph and now make a connection like this. It's sawtooth signal, square signal, sine waveform, sawtooth square sine, sawtooth square sine. You can change it. Here I'm going to replicate this one. Great. It's my another signal, right? Two function generators are here. Two basic function generators are here. Both can generate same kind of signal. If I will take addition functions here, addition up to signal. If I will take a subtraction up to signal, it's addition up to signal and it's subtraction up to signal. Run. Now the first just second, subtraction in place of addition. Replace subtract. Here the sine waveform minus square waveform. The first one is sine waveform. So this one, sine waveform plus square waveform. So you will get a signal like this. Sine waveform minus square waveform. So you will get a signal like this. You can easily manipulate your signal. You can easily generate. You can take your own time. There's no hard and fast rule. There is no syntax. You can create your own signal. Okay. And you can add, you can multiply, you can divide. Suppose the signal is for the multiplication. Function is for multiplication. And both are the sine waveform with the same frequency. With the same frequency. There's no changes. Both have the same frequency, then no changes. Only there is, you can see a wonderful things here. This is a sine waveform, and this is also a sine waveform. Sine multiplied by sine, so sine square. So here I am getting the signal from 0 to 1, not minus 1 to 1. This signal is from minus 1 to plus 1. It's also plus 1 to plus 1. Sorry, uh, minus 1 to plus 1. But here you can see the signal are only 0 to 1, because the half of the signal, because the half of this signal, okay, I'm getting in the below section, and second half is just opposite, sine square concept. But if here I will change it frequency, if I will change a frequency of a lower one, suppose the frequency is 100, then we'll get a signal like this. If the first one frequency is 1, then we will get a signal like this. You can easily design this kind of the signal related concept for your understanding. This hardware is not involved, any kind of hardware is not involved here. So you can write any kind of code as per your own knowledge, as per your own, okay, concept. You will not encounter with any kind of shortcut circuit and others. Is it clear? Great. Suppose the first one signal is, okay, here I'm going to reduce the frequency. Suppose it is 50. Suppose the first one signal is a square signal. Square signal. So now you can see there is a small phase change shift only. Now you can see there is a small phase shift. You can see here. Now you can see the phase shift again. These are not 100% as much as accurate like your communication background, but yes, you can create a, you can simulate, and you can design various examples for your understanding. Later you can go and you can break down your signal, and you can put your other concept, okay, signal, sorry, that communication based concept. If I have signal between 0 to 1, same, not 0 to 1, okay, due to the phase shift, it's 0 to minus 2, so I'm getting the signal like this. If the frequency will be, amplitude will be 0.5. Anyone? So now here I am going to create a multi-tone signal. Multi-tone signal. This multi-tone signal create a control, tone frequency, create amplitude, take waveform graph. It is a multi-tone signal. I think the signal is not properly visible. So here one will be 10, another will be yes 50, 100, 200. We have this four amplitude round and run. If it is a one, so you can see the signal like this. So there's four different signal are here. Four different signal are here. Four amplitude. Amplitude is will be a 2, amplitude with 1 and zero point 0.5. In one signal, you can see how many signals are there. Now, can we put a filter here? Right click, come to the Express VI, signal analysis. There is a filter. Take a filter here, press OK, but OK. Low pass filter here I am taking. Cutoff frequency, create. I am going to create control. And this signal will display the waveform graph. Now, the cutoff frequency is 100. I need only my signal. Now you can see the cutoff frequency is 10. That's why I'm getting a proper sine waveform for this. And amplitude is near about 4. And amplitude is, okay, this. It will be 11. So I will get slightly distorted signal. If I will get the cutoff frequency 100, so I will get, so not 100, if I will get 50, so maybe I will get the addition of two signal, this signal and this signal. Okay, are you getting the concept? If not, so I will explain. I will break the multi-tone signal generator and I can explain. uh yeah, so no issue. Right click, come here and take a sine waveform. Create constant. Create constant. Sorry, constant. Create a waveform graph. Signal number 2 is for signal number 2. Is for the signal number 3. Let's take only 3 signal. Frequency is 10, amplitude will be 2. Frequency 50, amplitude 1, and frequency 100, amplitude 0.5. 0.5. Generate 3 signal. The frequency is very high. Frequency is 100. Okay. The frequency is 100 for this signal. Frequency is 50 for this signal. Frequency is 20, this 10 for this signal. Let's add 2 signal. Okay, using this we can add all the signal. Addition of these 2 signal and addition of all signal. Clear? Let's see how our signal will look like. You can see here. Addition of these 2 signal is look like this. Addition of these 2 signal. Addition of these 2 signal. So give the name signal A with the A, signal B, signal C. Is A plus B, sorry, A plus B, and this one is A plus B plus C. A, C, and B. Is clear? Signal for A, signal for B, signal for C, A plus B, and A plus B and C. 3 signal are here. Right click, come here and take a filter. Here I am selecting a low pass filter, but our third order low pass filter only. Make a connection with the final signal and take a indicator. Let's see how indicator will display the signal. Okay, this one only small mistake, and the mistake is here. Create control. Okay, it's my cutoff frequency, and now you can see here the my cutoff frequency is 10. So when I will keep the cutoff frequency 10, so I will get a signal like this. Are you able to see? So here I'm getting a signal like this. If my cutoff frequency is near to 50, so I will get a signal like this. Okay. 100, maybe I will get a signal like this. If you want to design So it is not a big program. You can try it. In this one graph, there is so many signals are there. Now, if you want, so you can see there's one signal with the frequency. There is one signal. The frequency is 10 and amplitude is 1. The frequency is 10 and amplitude is 1. Right? This one. This one, blue one. The frequency is 10 and amplitude is 1. So here I am going to manage plot 1, plot 2, plot 3, plot 4. I think 4 signals are there. So now here I am going to close the frequency 10. Now the red one. So red one is the amplitude is 1 and the frequency is 50. So in one graph, you can display various graph and you can perform your task without any problem. यहाँ पर कोई मिस्टेक हुआ क्या? एक ही सिग्नल दो बार ऐड हुआ है? Yes, one signal has been added 2 times. Yeah. Now the signal is look better. Okay. So shall we go on the next portion? Okay. We'll come back in the same phase later. Now, in this example, as told you, we had used one enumerate function palette. Here, I'm going to show you one example. Here, I'm going to discuss with you a case structure. Case structure. So, in this, there is a case structure. The case structure contain more than one cases. More than one cases. This button is a case selector terminal. This button is a case select terminal, and it is our case select label. Okay. In this case structure, there is only two options are available, true and false. So you can take a Boolean function, you can take a Boolean functions and you can control. Why? Because it is green and it is a Boolean control. And you can create two options, add, subtract. It is add and subtraction for you, not for the use. Okay, it is the add and subtraction you had mentioned, and you can give any student or any other person to add and subtract. Okay, but here you can see the true and false, only two conditions are here. If you will take a two number like a, like it b, and you want to add this number, you want to get the result. Okay, no, not here. For subtract, false addition, you can take subtract functions. In this way, you can create only two functions, two options. 2 plus 2 plus minus 3 is equal to 1. If you will get 2 minus 3 is equal to 5. It's our case structure, right? Using this case structure, we can control more than two mechanisms. Okay, many mechanisms, more than one mechanism. If you want to control, if you want to control more than one mechanism, you want to write more than one algorithm. Okay, so you can use case structure easily. Case structure contain more than one subdiagram. Case structure contain more than one subdiagram, and each subdiagram you can design your different condition, your different cases, and you can create your different logic. And this case you can control by this case select terminal, and case selector level will give you the info about that particular case. But the LabVIEW programmer developers always suggest to avoid a string as a case, a string function as a case select terminal, a string function as a case select terminal. When you will connect a string function as a case select terminal, so there will be 100% chance for data mismatch. Suppose it is not a false, it is suppose okay. It's here, it's not a okay, it's capital O and small k. It's true. Then if you will add one more case after this one, and you will try it NOT, capital N, small o, small t, right? And here I am going to write, here I am going to uh, write one info. Uh, valid input, valid input and OT not, valid input not. Let's come. Valid input true. Okay. Create control. Sorry, create constant valid input okay or wrong. यहाँ पर मैं क्या बताना और बोलना चाह रहा हूं. Here I want to explain the programmer developers and LabVIEW users, okay, prefer to avoid the case select string as a case select terminal. Why? Suppose now you can see there is three cases are registered. Okay, that is associated with default, true, and not. Defaults means if any kind of data mismatch will come, if the case sensitivity will not, okay, the case are the completely case sensitive, if the sensitivity will not, okay, okay, so it will go to the okay or default. Suppose here I am going to run valid input okay or wrong input. I didn't enter anything. I didn't enter anything and it's selected a valid okay, it's selected valid input anything or wrong input. Suppose here if I will select true, we know very well the true is registered here. The true is registered here. True is a registered case. But if I will run the program, so again I will get valid input okay or wrong input. Why? Because this true is not equal to this true. There is only one difference. The T is capital. The T is capital. Okay. Yes, you can run more than two algorithm using case structure. You can add n number of algorithm. Okay. Value is not that much defined. You can, so there is three case are registered. Suppose here if I will put capital N O T is not, so we will get a valid input not. Suppose capital in place of capital N, capital O, capital T, if a user will put not like this, so it will shift you to invalid or wrong input. Getting the points? So we cannot control the users. Okay, what kind of input a user will enter on your program, you cannot control to the user. You can just protect your program. You cannot say ever the user will not encounter with this kind of problem, or user will not create this kind of situation where they will generate a default or wrong value. Definitely, if user will do everything correct, suppose if user will do here everything correct, capital not, and after that user will enter a space, so also it is wrong. If user will enter, so also it is wrong. That means we cannot control the user. We can only protect our program. So how can we create an algorithm where user should depend on us and user will enter the value as per our choice? So there we can use enum functions. Enum is a type of data type which is a combination of numbers and string. Number and string. Enum is a kind of enumerated data type. You can take enum from this enum and ring data type group. You can select enum, from enum entering data type groups. Okay, you can select it from here, and after that you can open it. Here the add item are available. Add items are available. Open the add item. When you will click and come into the edit item, when you will click and come into the edit item, you will get item and values. One, you will get items, there you will values. Item you can fit by yourself, like add, then you can subtract, then you can set multiply, then you can set divide, add, subtract, multiply, and divide. Add, subtract, multiply, and divide. Four items are here. So for the four items, it's generated a numbers, unique numbers, 0, 1, 2, 3, 4. It's generated a 0, 1, 2, 3, 4. And now press OK button. You can see four items are here. Got it? Now come here, come into the structure. Take a case structure. So first one is add, second one is subtract, third one is multiply, and fourth one is. So we have registered four cases, and each and every case will perform perfect signal, okay, perfect data, and the perfect conditions, and algorithm will work fine. Let's check once. Sine and square, two signal I have taken. First function is addition functions. Take add functions here. Second is subtract function. You can take a subtract function here. Then multiply functions. You can take multiply functions for both. Take divide functions. You can take a divide functions. Run. This one, okay, addition of two signals. Now you can see these are the addition of sine wave and square wave. Let's click here, subtract. This is the subtract. Click here, multiplication. This one is the multiplication. Divide. This, okay, divide. And this one is divides functions. Multiply, subtract, addition. right? Suppose the frequency of square is constant, and sorry, frequency of square is 2. Run. Addition of two signal. Now you can see the addition of two signal. Subtraction of two signal. It's subtraction of two signal. Multiply. Sorry. Multiply of two signal. Suppose I want to add one more signal here. Concatenate. Suppose I want to add one more signal here. Concatenate signal. Concatenate options. So edit item. You can add here concatenate. You can create one more add conditions. Yes, you can come here. Control B, concatenate input, get waveform component, build. If I will take the concatenate, so how output? Okay, now you can see both signal I am getting. So using the enum, you can design using the enum. Okay, uh, you can give a control option. You can give a specific options to your user or your customer where they will select whatever, okay, as per your suggested option. वो अपने हिसाब से कुछ भी नहीं डाल देंगे, and you can prevent your case for the various kind of error. Is clear for all of you? Okay, you can take the video from the Joshi sir and you can practice all the things. Whenever you will face any problem, okay, you can write me and you can write to me. Now, there is one example portion comments of for loop. In this for loop, there is a very beautiful functions are available, and the function name is shift register. There is a beautiful functions are available in for loop that name is shift register. Suppose this for loop will run, this for loop will run 10 times, and every time it will generate one value. This for loop will iterate 10 times, and every time it will generate a value. And the for loop, whenever you will run a every time the for loop will run, it will generate some value, and we can read that value at the same time. We can read that value at the same time. Either we can read that value after complete the execution of program. Right? It's completely true. But there is a shift register that provides you a facility where you can call your previous iteration data into the current loop. Where you can call your previous iteration data into the current loop. Now, how? Right click, create a shift register. This shift register first will take the data, and on the next iteration, it will give you the particular data. The first iteration, when it will run on the when your program will start execution, तो पहले iteration में ये एक value generate करेगा. Who? This I will generate a value, और वो value ये पहले accept करेगा. It will accept that value, and on the next iteration, when it will generate a second value, this numeric indicator will display the first value. Suppose here I am taking one functions, increment functions. This I will generate value from 0 to this I will generate value from 0 to 10. In the first iteration, the I will generate a value that will be 1. At that time, numeric will generate numeric 2. Okay, the I will generate value. Sorry, the when okay, when I will run the program, the I will generate a value 0 and it will generate value 1. When the numeric will display that value 1, that is the first iteration. On the first iteration, this arrangement. अब हम बात करेंगे सीधा 1 से. Now loop will start generating value from 1. When the loop will generate value from 1, okay, in the first iteration, it will display the 0 value. Why? Because it is already present in sliced. And in the second iteration, it will display 1 and it will display 2. क्यों ऐसा क्यों होगा? Why? Because in the first iteration, when it will generate a value 1, it will display at the same time, and this shift register will receive the data and it will hold the data for the next iteration. And on the second iteration, when it will generate a value 2, at that time, this shift register will release that previous data, and that value of data will be the value of data is 1. और जब थर्ड आइटरेशन होगा एट दैट टाइम इट विल जनरेट अ वैल्यू 3. तो इससे पहले वाले आइटरेशन में व्हाट एवर डेटा इट हैज टेकन, सपोज इट हैज टेकन डेटा 2, so it will release the data. Means each and every iteration it will using the shift register you can transfer your current iteration data to the next iteration. Other you can uh, receive your previous iteration data into the current iteration. इसके लिए एक बेस्ट एग्जांपल मैं आपको देता हूं. Let's take a better one example. Right click, take a shift register, take a add functions, take a number here and place it. Now you can see here it's generating a table for 2. So let's try to examine and let's try to explain the concept. 0, first time when it will run, it will enter 0 and it will give you value 2. 2 plus 0, 2. It will pass the data to, it will pass the data that 2. And second iteration, it will generate 2 plus 2 is equal to 4. Then again, it will pass the data 4 plus 2 is equal to 6. It will pass that 6 value. 6 plus 2 is equal to 8. 0 plus 2 is passed 2. 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. 8 plus 2, 10. 10 plus 2, 12. Okay. Now, here I am taking one add functions again. Right click, take a shift register. Now you can drag the shift register and you can increase the size. We call it stack shift registers. You can read all these things from online and other platform. It is stack shift registers. As we know, this shift register avail the last iteration value, and this shift register will avail the last to last iteration value. This shift register will avail the last iteration, and the lower one will avail last to last iteration value. It will create a Fibonacci series for you. First, it will enter 0 and 1. 0 plus 1, 1. It will transfer here. When it will transfer the 1 here, this 0 will shift here and new 1 will come here. Then again, 1 plus 0 is equal to 1. At the third time, when the 1 will come here, the previous one will come down here and the new one will here. 1 plus 1, 2. Then the fourth time, when the 2 will come here, then 2 will go here and 1 will be here. Then 2 plus 1 is equal to 3. Look at here. 0 plus 1, 1. 1 shifted down. 1 plus 0, 1. Then 1 shifted down. 1 plus 2, 2. Then 2 shift down and okay, 1 shift down and 2 come. 2 plus 1, 3 plus 2, 5 plus 3. If you want, so you can try this one. गाना बंद करो यार. Okay, so let's go into the one more topic of today, and the topic is property node. Anyone is here? Right click, come here, take a numeric control, and when you will take a numeric control, automatically a terminal will come out on the block diagram. Then create an indicator. So this one is numeric controls and numeric indicator. Now, when you will right click on numeric control, so you will get a shortcut menu. In this shortcut menu, whatever you will see, all these are the properties. Now you can see here, there is a label. This is label. That's why whatever I will change here, same change, it will register on block diagram. But if I will close it here, if I will uncheck the label, and if I will open a caption, and if I will make any change, so it will not affect into the block diagram. Here I'm going to run the program, and whatever the value here I will set, okay, it will display at the same time. But I want to prevent my program. I want to put some limitations like this. I want to set a minimum range is -10, maximum range will be +10, and unit step size will be 0.5. Means increment हो तो 0.5 के रेंज में होना चाहिए. So for that you have to right click, you have to come into the create, you have to come to the property node, and in this property node, data entry limits, data entry limit, data entry limit, select all, change it to the right, create constant, minus, sorry, that's 10, minus 10.5. Run the program. Value will not go less than -10, and value will not go over the +10. In this way, using this program, we can control the property. We can directly change. Programmatically, we cannot control our any functions, any object. Programmatically, we cannot control any objects. That's why we need a property node. Using the property node, we can target and we can easily control, or we can easily uh, change the property of our any controls or indicator, which we cannot do programmatically. Programmatically, we cannot control any, we cannot change any property of our control or indicators. So to change the functionality, behavior, look of our program, we can use a property. We can use property node. Always I want to keep this controller. Always I want to keep this controller in my initial location. So for that, I can come right click. I can right click. I can create here, and I can come into property node. I can come into position here. In this position, create constant 0 and 0. Now the location is 0 and 0. The location is 0 and 0. No matters where any, if I will put it anywhere, automatically it will go to the 0 and 0 location. Programmatically, I cannot change, but yes, due through the this property node, I can create this kind of changes. There is one beautiful change. There is one beautiful program. Sorry, there is a beautiful uh, option on the property node, that is visibility, visible, run. Now you can see, if I will close it, so it will be not visible to me. I'm going to show you some example. How can you utilize this one? Right? Look at here. Right click, come here and take a string array. String. Right click, change it into the array, increase the size and make it 2D array. PHYSIC. Physics, math, bio, chemistry, programming, social science. History. These are some subjects. Okay, these are some subjects, and your marks is 89, 98, okay, 92, 67, 61, 21, 72. These are yours. Okay. So now right click here and taking a table, uh, a boolean button, stop button, and the name will be a table, table table. It's marks table, mark table, like actions, like list. Right, right click, come here, property node, visible, run the program. Is not available. When I will click it, then it will show. First task done. Now right click here. Now you can see here the my marks are present on the column number one. My complete marks are present on the column number one. So now I have to break down my array. So for that, come here and take a initialize array functions. Sorry, take a index array functions. You will use all this program soon when you will try to create. You will use all these programs, all this logic soon when you will use your when you will try to create algorithm for your communication system or modulation. Now these are my marks, right? But here the my marks are available are present. Here the my marks are available in the form of string. So I have to convert this string value. he- I have to convert this string value into the numeric. So for that, I need I need to come into the string function palette, number to string conversion. Then here you have to find out decimal string to number. Decimal string to number. Now we need a total number. So for the total, you need to use same kind of logic you need, same kind of functions. And final, you can get the percentage. Finally, you need the percentage. If I will close the program, total marks, okay, marks, total marks and percentage. In this way, you can design, you can give the more creative concepts, okay, to your functions, or you can control, you can give a control, proper control on your program using and only using the property node. Okay, now look at here. There is one functions. Okay, there is one functions on. Suppose this one is suppose this one is my temp, temp temp system. Okay, temp measurement system. Suppose this one is my temperature measurement system. Okay, when the temperature will rise more than 40, so it should blink. It should blink. So for that, right click, you can come here and you can come into the property node and there is blinking, blinking. Right click, create control, change all to right. Okay, here, right click, create local variable. This value, value is equal to, if the value will be greater than, if the value will greater than 30. If the value will greater than suppose 35, so it should blink. If the value should greater than 35, so it should blink. Let's see. Run. It should start blinking to display some kind any informations like, and you can display some information. Your system is not working. Okay. The temperature is more than a certain degree. Whatever you want, you can give up information here. Suppose this one there is a fixed temperature. Okay, fixed temp. How can I fix this temp? Uh, okay, ideal temp. Okay, ideal temp. Here I want to set an ideal temp, and I want to set this ideal temp 34 degrees centigrade, and I want to fix it. I want to fix. No one can change the value. So here I can come into the create. Okay, we can come here and we can come into the disable option. We can come with disable option. After that, change to right, create constant, and disable. Now no one can change anything because the particular function is disabled now. So it is a property node. You can design or you can change your program design concept using the property node very easily. Now getting the point. One more example related to the property node. Definitely, this example will blow your mind. And suppose let's try to create one table for a number. I want to create a table for number. Okay, any number. So for that, I need to write a code like this. Using this logic, we can create a table, right? Using this logic, I can create a table. And whenever I will create a table, whenever you want to create a table for any number, always you need to expand that table. I want to solve this problem using the property node. Let's see how can we do it. Right click on the array, come into the create, property node, number of columns, number of rows. Number of row is here. Change order to right. Right click, come here, take the array size, place here, and make a connection. No matters how long your array, it will automatically expand your array size. It will expand your array size. Okay. Suppose I want to create a table for 1 to 10. Suppose I want to create a table for 1 to 10. So I don't have any idea how much I need to expand it. I don't have any idea how much I need to expand it. Suppose I want to create a table, sorry, Control T. And here I don't have any idea how much I need to expand my table. So for that, I can come into the property node. We can come into the number of columns and number of rows. Change all to right, drag it, column and rows. After that, right click, come to the array. This matrix size, take a function here, make a connection like this. It is for the row, so column, and run the program. It will create a table for you. It will create a table for you automatically. It will expand your table as per your required size. Please try if you want. Okay, so let's go on the next and final topic. Am I audible? Sir? Okay, so the last and final topic is our file IO. File IO is a really a beautiful and dynamic data storage platform of LabVIEW. So in this file IO, you will get a write manual file and read manual file, write delimited spreadsheet and read delimited spreadsheet, write and read delimited spreadsheet, write manual file and read manual file. So already we have seen the how can we use the write measurement file, right? So here I'm going to show you one more example. How can we create it? Right click, come here and take a sine waveform. It will generate a sine waveform. Whatever the signal it will generate, we can easily store that signal. So write measurement file, when you will take it, you will get a configure write to measurement file. Here I'm going to set a location and in IIT Delhi location, SIN is sine data. Okay. So now the file format is LVM. What? The file format is LVM. LVM data, I am going to save it. You can make a connection like this. And after that, here, if I will run a program, now you can see assign data.lvm file is available here. Again, I'm going to open the same LabVIEW, double click and open here. Here I'm going to set it the second, okay, second sign and press OK. I'm going to change it Excel, place here, run. Now you can see here the sign data, and second sign, one more file has generated here. So in this way, you can store any file, any data, okay, string data, real string data, yeah, real time data. So now come to the next example. How can we read the data? So if you have already written file in your PC in the form of LVM or text, so you can easily read that file. Suppose in my PC, I had already created one LVM file and the LVM file name is signed data LVM that I had created, which I am going to target here. So inside the IIT, triple IT Delhi and signed data.lvm, okay. I pressed button okay. Then come here and take away from graph and you can read and display the data. Okay, I am reading this sign to sorry sign data.lvm. Okay, so it's a way how can you read your data. Okay. Now in the file IO, let's go to the another step. In this file IO, these four are high level. These four are express or high level programming file. Why? Because all the open, close, and read and write options are available in single VI, in single program. These four are high level, but these are low level program. Later, I will explain these two. Now here I am going to write a low level program. Open, close, write text file. Open, write text file, close file. Open, create and replace. Make a connection, the open, create or replace. If there is any already written a file and you want to re-edit, you want to okay, already, if there is any already written file, you want to read the data, you want to re-edit the file, or you want to access the file, so you can open that particular file. If you want to replace the particular file, so also this function will support. If there is no any new file has created, so also you can create a new file. Now let's come into the file format and take a file path control. Make a connection this file path control with this. Now create a constant. It is a operation operations. What operations you want to do? So operations here I'm going to select okay, replace or create. Either replace our designed file, either create a new file. And here I'm going to take a string control where we will write something. Suppose here I want to write, suppose here I want to write, I want to store this data in this data on my computer. I want to store this data and on my computer through this program. So this is the programming for the particular application. This is to write a program. If you want to write anything in your computer, like in the form of text file, so you can use these functions. You can use this programming, this algorithm. Okay. Now, open, create, and replace will open that reference line. It will be help you to target the particular location or the particular path. So, okay, of the particular file, particular target location or particular path of the particular file. whe- Okay, where you want to write or in which you want to write something, and after that it will close the particular function. Now, here the operation is replace and create. So what we can change here? We can change here. So to change, so first we need to change a small. Right click, browse option, and here file or folder, and new and existing we have to change, and then we have to press OK button. How? Right click, browse option, file or folder, new or existing, and press OK button. Now browse the option by clicking inside IIT Delhi. I am going to see the SHIFT shift. The .txt. .txt is a extension. .txt is a extension for text file. Here I am going to show you. Here this no file are available now. Here I am going to run the program. Shift register text file are available here, and now you can check it. And now you can check it. What is written here inside? Whatever I have written here, same thing is written here. Suppose PEARTR sir, sir. Now here I am going to close everything and run. Let's open. Dear sir, LabVIEW shift register used. In this way, you can write your data. Open the LabVIEW, come into the block diagram. Suppose there is a sine wave generated. Okay. Suppose the first half program is here, where I want to generate a sine waveform, and I want to store the data in the form of Excel, in the form of text sheet or Excel. So it will not help me to save. So here, the green light which going, that's called reference. That's called reference. This line are called reference. Reference always create a unique identifiers for your program. Where and which line? Okay, using this path, by using this path, when okay, we can target a location. By using this path, we can target a location where we want to store our data. So for the particular path, this reference create a unique identity for this program only, for the particular program. Okay, and for the particular program. So first it will target that hardware, and it will open that, sorry, target the path file, okay, for that particular folder, and it will open the folder. After opening that folder, it will generate a reference value. That reference value will indicate this indicate That terminal value indicate this write to text file functions. Okay, where you have to save something, and after that when it will done the task, it will indicate the this close file. Okay, task has been done. Now you can remove the that your refnum value. So using this way they can create they can easily write and construct the file. Okay, we call it refnum in and refnum out. Now, the data type is numeric. We know the data type is numeric and it will accept only the integer type. It will accept only the string type. So I need a converter from the string function palette. String, this last column, string, decimal string. Not decimal, I need a fractional string. A fractional string. Let's see. Now you can see the data, fractional string data are here. Suppose here, in place of this, if I will write doc file, .doc file, and if I will run .doc, so now you can see shift register document file has been created here. .doc file is created here. If I will write here csv file, .csv file and run, so it will create a .csv file for me. Okay, it will create a .csv file for us. Uh, If you want to read any file, so open, create or replace, close, read text file, make a connection and open the label. Right click, come here, take a file path, create operation, create constant operations, open or create. Yes, let's take open because we want to read it. Create indicators, write file, read it. Yeah, we can easily read like this. Okay, we can easily read. Suppose in your PC there is any .csv file is present. .csv file is present in your PC. So how can you use it? So you can read that .csv file using, you can read that .csv file using a normal file path, and in the form of dbl, in the form of string. I am going to read in the form of dbl. Yes, dbl all column, create indicator, format, is- okay, and delimited comma. Here, run. I'm going to select this one. Now you can see I can easily read my Excel sheet. We can read our Excel sheet easily using delimited spreadsheet file. And this all basic things will help you to get, okay, uh, okay, this all basic things will help you when you will try to create your example for our application for. Okay, sorry. Okay, all this all this basic will help you to complete your task and application when you will work for the modulation toolkits and others. So thank you for your time. I think I have covered all the given topics.
So, thank you, Nitish, for your valuable time and whatever you have taught. That will be very, very helpful for the students. Definitely, it will be very helpful in designing the code and hard coding everything. Right? You have explained each and every like the very, very important functions, and so participants. So very few students are there. So, do you have any doubt, Sagar, Ullas, Varun? Okay. So this video is also there. So we'll be sharing this with the participants who are not able to attend the session because of their other uh, commitments. So and this session will be very helpful them for them to in basically the second session which we have planned on 24th. So they will be able to with this 17 to 24 time, as I've just said, that they can utilize this for exploring the lab view, designing a number of codes and whatever that has been taught to explore them and design different examples out of it. And so when the modulation toolkit will be there, they can at least design it, they can understand it in a more better way. So with this, so and I would like to tell the students that Nitish was not well, but still he agreed to conduct the session. So thank you, Nitish, for your time.
थैंक यू सर. सेकंड हाफ में तो मैं पूरा का पूरा ऐसा था कि अभी 3 बजे के बाद बोलने की हिम्मत ही नहीं था सर.
हाँ नहीं, वही मैं समझ पा रहा हूँ. थैंक यू
मैं
बहुत.
खुद से प्रोसेस भी नहीं कर पा रहा हूँ कि मैं क्या बोल रहा हूँ.
हम्म. नहीं, बहुत आपने काफी अच्छा करा है और डेफिनेटली इट वाज वेरी वेरी इंटरेस्टिंग एंड हेल्पफुल. So with this, I think I can stop the recording and so
थैंक यू ऑल ऑफ यू सर. मैं चलता हूँ सर. क्योंकि मुझे मेडिसिन भी लेना है।